All right, so let's go ahead and go over worksheet 60 real quick. Number 1, I think we did together, but number 2, take a look at number 2. Right, we've got a leg here that's length 4. We've got a leg here with an unknown length. We'll call that B. And then, of course, we've got our hypotenuse directly across from our right angle. That's going to be C. So we can call our leg with length 4. We'll call that A. Now, all we have to do is set up our equation. A squared plus B squared equals C squared. Right? A, we said, was 4, so we'll plug that in there. We don't know what side length B is. That's what we're going to have to look for, so we'll call that B squared. And we know that C is equal to 9, right? Remember, our hypotenuse always has to be C. Now we just do these exponents. 4 squared gives us 16. 9 squared gives us 81. And then we can subtract 16 from both sides. Right, just like our equation solving days. These 16s cancel out, leaving us with B squared on the left. 81 minus 16 gives us 65 on the right. Now we got to get B all by itself. Right now it's almost by itself. We're squaring our B. So we're going to have to do the inverse of squaring, which is taking the square root. And again, we always have to do that to both sides. Now if we want to break this down on the left, B squared, that's just B times B. And 65 ends up being 5 times 13. So now remember, at this point we have to look for identical pairs that we can bring out of our square root. On the left, we've got a pair of B's that comes out. And when we bring those B's out, again, they fuse into one singular variable B. But there's no pairs that we can bring out over here, right? 5 and 13, we can't split those up anymore. They're not the same term, so we can't bring them out. All we have to do is just multiply them back together and get B is equal to root 65 units. Not just 65 units, right? It's got to be the square root of 65 units, which ends up being about 8, right? A little bit more than 8 units. And that would make sense that B is equal to, I'm going to do a little squiggle equal sign. That means that it's about equal to, it's not exact, but B is about equal to 8. Right, and that makes sense. If this side's 4, this side's about 8, our longest side here is going to be 9. That's our hypotenuse. If you're wondering how did I get about 8, because the square root of 64 would have came out nice and even to give us an answer of 8. So the square root of 65 is just going to be a little tiny bit more than that, 8.05 or something like that. Let's see. Square root 65. Oh, I was close. 8.06. So yeah, just a little bit more than 8. We don't have to worry about that. We want the exact answer written like that. All right, we're going to do the evens here going down to number 4. Again, we've got a leg of 10. We'll call that A. We've got an unknown leg. We'll call that B. And then directly across from our right angle always points right to the hypotenuse. That's got to be our C. So we got 10 squared plus B squared equals 13 squared. We apply these exponents. 10 squared is 100. 13 squared is 169. And then we're going to subtract 100 from both sides. Remember, we want to get B by itself. So anything that's around B, we got to move that out of the way. Those 100s go away, leaving us with B squared equals 69. Let me go ahead and take the square root. Now for this one, again, the B's come out on the left, giving us just B. But 69, we can't really split that up anymore. If we divide it by 3, then we get 23, and we can't split 23 up anymore. So it's kind of like number 2. We're just going to leave it as the square root of 69. We have to remember to write units. Even I almost forgot there. Square root of 69 units. Now I would jump down to number 6, but it's kind of similar to numbers 2 and 4, so I want to do something a little bit different. Let's take a look at number 5. Now number 5, our triangle's oriented a little bit differently, but we're still able to tell which side is the hypotenuse by following this right angle. Right? It's pointing right down to the hypotenuse. That's going to give us a C value of 5. Here's one of our legs, we'll call that A. Here's our missing leg, we'll call that B. So we got 3 squared plus B squared equals 5 squared. 9 plus B squared equals 25. And then we'll subtract 9 from both sides. These 9s go away, leaving us with B squared equals 25 minus 9, which is 16. So we can see this is going to turn out a little bit different when we take the square root of both sides. On the left we get B times B, and 16, well that's just 4 times 4, right? So now not only do we have a pair of B's that we can bring out, we also have a pair of 4's that we can bring out on the left, leaving us with B equals just 4 units. Now the square root of 4, once we bring that pair out, if there's nothing left over, which there isn't here, our square root just goes away, leaving us with only 4 units. And we know this for sure because, again, this is that special type of triangle we talked about, a 3, 4, 5 right triangle. Those are going to keep coming up and appearing as you go through your math classes, so it's definitely nice to start pointing out the patterns there. All right, taking a look at a couple problems on the back. We'll start with number 7 up here. Number 7, here's our hypotenuse directly across from our right angle. That'll be C. We can call 5 our value for A. 5 squared plus B squared equals 13 squared. Evaluate the exponents. 25 plus B squared equals 169. And then we subtract 25 from both sides. These 25s go away. B squared's left on the left. And 169 minus 25 gives us a nice 144. Our brains should tell us, hey, 144, that's a perfect square. So our answer is going to be B equals 12 units. Right, the square root of 144 gives us 12. Going down to number 9. Hypotenuse here is 9. That'll be our C. One of our legs is 3, and one of our legs is just B. So we've got 3 squared plus B squared equals 9 squared. It gives us 9 plus B squared equals 81. We'll subtract 9 from both sides, giving us B squared equals 72. And then we'll take the square root of both sides. 72, I know that one can be split up, but I'm not sure exactly what my factors are going to be, so I'm going to do a factor tree here. Now, what two numbers multiply to give us 72? If we think back to our multiplication charts, we know that 72, that's just 8 times 9. We can break 9 up into 3 times 3, and we can break up 8 into 2 times 4. Now, what I've seen a lot of is people forgetting to then break that 4 up again into a 2 times 2. That gives us 5 prime factors of 2 times 2 times 2 times 3 times 3 times, yes, only 2 3s, I apologize. 2 times 2 times 2 times 3 times 3. And on the left, of course, we have B times B. So the B's get brought out. And over here, we have 2 identical pairs. We've got a pair of 2's and we got a pair of 3's. So when we bring those out in front, we always want to multiply them together 2 times 3 giving us 6, b on the left. But this lonesome 2 in here doesn't have a pair, right? It doesn't have a twin that it can get pulled out of the square root with, like the 2 and the 3. So that 2 is going to stay behind inside that square root, and our answer is going to be 6 root 2 units. Kind of a lot of work there for that one, but it's because we had to break down the 72. Now, number 11, I want to talk about real quick because we've talked about 3, 4, 5 triangles a little bit. So I don't want you to look at this and go, oh, there's a 3, there's a 4, my missing side must be 5, right? Because with a 3, 4, 5 triangle, which of these side lengths has to be the hypotenuse? Well, the hypotenuse has to be the largest side, so 5 needs to be my hypotenuse in a 3, 4, 5 triangle, this special type of triangle that we see a lot of. Now, my hypotenuse here is not 5, right? If we look across from the right angle, we see that our hypotenuse here is 4. So even though this looks like it might be a 3, 4, 5 triangle, it's actually not, because if it was, our hypotenuse would be 5. It's our longest side, right? So we can just solve this like normal. 3 squared plus b squared equals 4 squared. 9 plus b squared equals 16. Subtract 9 from both sides. And get b squared is equal to 7. Final step, of course, is going to be to take the square root of both sides, giving us b is equal to root 7 units. Root 7 units. All right. Now, for the sake of time, that's going to be all that we go over in detail here. I'm going to quickly run through all the answers that we didn't get a chance to talk about, just so you can check your work. I'll do them here in blue pen so you can tell the difference. Flip it back over to the front if we want our answers here. Again, we're not going to work these ones out, but you can use what you learned from us working the other problems out to hopefully get these done on your own time. Number 1, we get the square root of 72, which breaks down into 7 root 2, or I'm sorry, 6 root 2 units. Don't know why I said 7. For number 1, we did that one together though, we should know that. Number 3, we end up getting the square root of 23 units. 144 minus 121 gives us 23, and then we have to take the square root. Down to number 6, this side here is root 3 units. Right, we take 4 minus 1, that gives us 3, and then we got to take the square root. Right back to the back here, just to get some answers checked. Number 8, we're looking for root 128, which when simplified becomes 8 root 2 units. Right, 64 times 2 gives us 128, and that 64 nets us out in 8 when we bring it out. Number 10, we end up with root 45, which simplifies to 3 root 5 units. Almost forgot again. Number 12 is a nice even answer. We just got 5 units. Right, 169 minus 144 gives us 5. Well, it gives us 25. And then when we take the square root, we get 5. Number 13, we're looking for root 108, which when simplified is 6 root 3 units. And number 14, we got root 44, which simplifies to 2 root 11 units. So there's half work, half answers for worksheet 60. Hopefully you're able to kind of pick up what I'm putting down here with this. But if not, we'll have time on Tuesday when we all come back from our 3-day weekend to go over this a little bit more and answer any questions that you might have.